Okay, so welcome to the 2022 question P2 higher level on perspective in DCG. So there's a quick view of the model there. It's going to run back to all the question there. So we've got the plan view and elevation of a portable coffee trailer. Alright, the surfaces B and C are inclined at 25 degrees. The scale is 1 to 100. You can see a quick view of the perspective drawing there from the marking scheme. It's a big question, by the way, so that's just worth noting. To get the plan view in roughly the middle or positioned on the right of the top middle of your sheet. So the scale is 1 to 100. I'm going to have to measure, so 50, 50, okay, and 3.5. So I've divided all the measurements by 100. I converted meters into millimeters and then knocked it down to, by 100, divided by 100. So essentially add on 0 to each single figure for the meters. Alright, 5 meters obviously being 50, 1.5 meters will be 15 millimeters. Now we'll mark the distances going down: 4, 4, 15 and 10 millimeters, and on the left hand side it's going to be I think it's 2, 4, 2. And there's the little overhang there. There's a little ledge for the coffee dock that I'm drawing in lightly. There's now be starting on the roof. Then there's the ridge line that's gone in heavy, that's in the middle of it. Then you can see those lines joined together, the inclined lines for the roof surfaces. There's surface C being done. There's the end of the trailer. There's the hidden detail in plan view for the little ledge for the coffee. Now, surface B, surface C, they're inclined right. The spectator S is 16 millimeters from corner A. Notice corner A is not on the physical object in plan, and it's located down 60 degrees and the picture plane touches point A. And the horizon line is 7 meters from the ground line, so 70 mil. Now here's the object in 3D, the plan view, the spectator 60 degrees from corner A. Okay, the spectator has a height of 70 millimeters. The vanishing points will be on the picture plane. There's the construction of bisecting the angle there. So you can join the two outermost corners of the grid or of the object, you'll get the same thing. Okay, you bisect the angle for the picture plane. So I'm going to locate the spectator now, and it's just a reminder of the size of the question. So I'm going down 60 degrees from corner A. Okay, I'm going to measure 160 millimeters from corner A. Can join the two outermost points of the grid or the object. As I said, you get the same thing. Now I'm going to set my compass to any length, swing two arcs, bisect the angle, draw on my center line of vision. Now my picture plane is perpendicular to that center line of vision, so I'm using sides and set squares there. So that's the picture plane there running through corner A. So no heights on the object will, in the perspective image, will be true heights. None will be true heights as no line on the object touches the picture plane. So there's no corner of the object on the picture plane in plan view. Now, we're going to get the vanishing points by going parallel to the parallel lines from the spectator. So vertically and horizontally, VP1, VP2. That's how we got them. Look, that's their parallel. And then this one, you see, they're parallel too. That's how we got the vanishing point, or the vanishing points on the horizon line. Now, we're going to draw perpendicular to the picture plane when we're constructing our, or bringing our vanishing points down. So I'm going perpendicular to the picture plane from each of the vanishing points down. My ground line and horizon line is going to be parallel to the picture plane. So here's my horizon line. Okay, and the distance of the ground line is 70 millimeters from the horizon line. So I'm just bringing corner A down so I can mark this 70 mil. So there it is there. There's my ground line. Remember, it's 70 mil from the horizon line, and the horizon line can start anywhere after the spectator. So you can see my horizon line and ground line on the picture plane. Now the next thing you would do is join all points in the plan view to, okay, the spectator that we briefly seen there in the SolidWorks there, where all the points were joined to the spectator on the grey lines. Now, because this is a massive question, you don't need to draw the whole line connecting a point to the spectator. So there's the picture plane in plan, and the perspective image is an edge view on that picture plane in plan. You can't see it. There's the vanishing points on the horizon line. HL for horizon line, GL for ground line. Now, look, you don't need to draw the line the whole way to the spectator. So connect the points, but you don't need to draw the line the whole way, because this is a massive question. So you want to use your time as efficiently as possible. So where those lines pierce the picture plane, what you do is you bring them back perpendicular to the picture plane. And you see all those points there, where those grey lines join the spectator and pierce the picture plane, they're points on the perspective image. That's that you can see in red there. That's how it works. They're points on the perspective image. So I can join A to the vanishing point 2 and A to, I'm going to do this corner first. So I'm going to take that corner down. I'm going to heavy that in between the horizon line. So that's that line there. And remember, the 3D diagram, the pictorial view, is the best info you have. Now, I'm going to take this point here in plan, don't mix it up with the ledge, where it hits the picture plane down perpendicular. I'm going to heavy it in because the true height is already marked in corner A and brought back to the vanishing point, so it reduces in height naturally for us. And there, I won't need to heavy it all in there, that's why I stopped a little bit with my rubber there, so I forgot the ledge would be there. So that's why I didn't need to heavy it all in. Now I'm going to do the height of the ledge, so it's up 2.8, so I'm going to mark up 28 mil on corner A from the ground line, join it back to vanishing point 2, there where it hits the edges. I'm going to join them back to vanishing point 1 and vanishing point 1 through them rather, and then I'm going to get the corner of the ledge there, the front left corner. I'm going to bring that down perpendicular, and then I'm bringing the back corner of the ledge down, and then I'm connecting them together. So there's the ledge done. Now I can get those two surfaces D and E that I'm going to do. So there's D as and E as edge using plan. So I'm going to join the bottom of the line brought down from A back to VP1. Okay, I'm going to get the corner of D, join the spectator, bring it down, and then I can heavy that in. I can connect them together. So there's surface D done, and now the end point of surface E joined to S. I'm going to bring that down perpendicular to the picture plane, and I can heavy that in. Now we can look at getting the roof surfaces F, G and H, but we're going to notice we're going to have to do B and C before we can do those surfaces really, because I need the height of them and I have to use auxiliary vanishing points, and the auxiliary vanishing point is going to be above VP1 parallel to the roof surfaces B and C, the blue and yellow. So look, there's the vanishing point in 3D. There's a triangle construction used to find the height of the vanishing point. The angle is parallel to the surface of the roof, that's where the 25 degrees is coming in. That's it. In plan view, that triangle appears as an edge view, but it has to be rotated down parallel to the horizontal plane to get the true height. So from S, I'm going to measure an angle of 25 degrees and it's got to VP1, and it has to be VP1 because the slope lines will be vanishing above VP1, not VP2. So I measure that 25 degree angle in, and now I'm drawing a line from VP1 perpendicular to S to VP1. So it's perpendicular, and that's the true height between the auxiliary vanishing point and the vanishing point. You see there, the auxiliary vanishing point is a point right over the vanishing point in plan on the picture plane. So we're going to get our compass, take this true height, and we're going to step it above VP1. There's our auxiliary vanishing point. And I can join that auxiliary vanishing point to the corners of the roof on surface B. So there I have them joined. And then I'm going to take that point on surface B, join it to S where it hits the picture plane down perpendicular until it hits this correct sloping line going to the auxiliary vanishing point. There, I can heavy them in. So on the roof, that does the other surfaces G, H and I. Now, to get the back of the ridge line on surface B, so FG and H rather, FG and H, those surfaces, and H can't be seen. So to get the back surface B, I'm going to bring it down perpendicular. I'm going to join the top left hand corner of surface B to VP2, because it's a horizontal line that vanishes to VP2. And where they intersect, that's it. And then I'm ready to attack surface C. So surface C there, we can see, okay, it starts just a little bit down from surface B. It's a meter. So along corner A, the true height line, I can mark the distances up of a meter, what were the 28, 32 and a meter. So 60 millimeters I'm marking up from the ground line. So I'm going to mark up 60. I'm going to join it to VP2. So that's the start corner C, and I can heavy in that line. And now I can join this top left corner C to the auxiliary vanishing point because it's sloping. I can bring the bottom left corner of surface C down perpendicular after it's been joined to the spectator, heavy it in. Now I can join it back to VP2. Now I can get the bottom right corner of surface C. It's joined to the spectator already. The bottom right, or I'm doing the top right corner there, sorry. Join that to the auxiliary vanishing point and heavy it in, and then I can connect them. And then here's the edge of the window that I was about to, I'm putting in the edge of the window opening there. And now that little line there is the back, is the inside of the coffee trailer. So I'm joining the top right corner in plan down to S. I know it's cut out there a little bit. Bringing it down perpendicular, and then I'm heavying it in. There we go. That's our completed solution. Now there'll be a few more things I'm going to show you in the video. I'll show you in a bit more in 3D what's happening. So you can see here what happens in 3D is we move our perspective image, okay, and we're going to rotate it down onto the horizontal plane so we can see the perspective image. So that's us rotating it down there. Right, that's why all those lines are perpendicular to the picture plane. And it's like the ground line, you can treat it as like another edge of a perspective image, and the perspective image is rotated about the ground line. So you'll see here in 3D coming up again. So there's the perspective image moved. That's it rotated down. There you can see them, and then the rotation lines here. See the way the arcs project as lines in plan, and the movements are perpendicular to the picture plane. So that's pretty much it. Thank you.